Solving right triangles 8.3b, which means there's an 8.3a, and I wouldn't want you to get lost or confused, so I hope you saw the one before this, and it's linked in the description in the geometry playlist. Using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. And this means we'll find all three side lengths and all three angle measures. Now I want you to remember that angles are labeled with capital letters and sides are labeled with lowercase letters. And it doesn't matter where they're located. Here the C is at the top, here the B is at the top. What's important to remember is that if this is angle A, then lowercase side A is opposite. Here's B, and lowercase side B is opposite angle B. Here's angle C, and lowercase side C is opposite. See? So don't get stuck thinking that the hypotenuse has got to be C because of the Pythagorean theorem. They're just variables and they take the place of an unknown amount, okay? And to solve a right triangle, we need to know two side lengths or one side length and an acute angle measure. So here we have two side lengths. Here we have two side lengths. Here we have an angle, acute angle, and a side. Here we have an acute angle and a side. So we could solve a right triangle with this information. So we can solve a right triangle and find the unknown measures, then we can round the lengths to the nearest hundredth and angle measures to the nearest degree. We're going to use two methods. This one we're going to use the Pythagorean theorem, and this one we're not, okay? So knowing that a squared plus b squared is equal to c squared, and we have a as a 5 and b as a 7.5, we do the math and we get 81.25. We can get rid of this little 2 exponent around the c by putting a radical sign around the 81.25, and we find that it's approximately 9.01. We know the measure of angle C is 90 degrees right here, and the measure of angle A is equal to the inverse tangent of the opposite over the adjacent legs, and that's going to be approximately 34 degrees. Now, the inverse tangent of 5 over 7.5 is the angle whose tangent equals 5 over 7.5, that opposite over the adjacent, okay? On your scientific calculator, you might have to push the arc key or the second key because we're doing an inverse function, all right? On the Real Calc app, you would just do 5 divided by 7.5 multiplied by, hit the shift key, and then tangent equals. And we'll get this nice long decimal that can be rounded to 34 degrees. And since the acute angles of a right triangle are complementary, the measure of angle C is going to be approximately this 90 degrees minus the 34 degrees. So it's going to be approximately 56 degrees. So now we know side A, B, and C, and we have angle A, B, and C. Okay? So here's the second method. We know the measure of angle C is 90 degrees, and this is the same triangle as this one, okay? And the measure of angle A is going to be equal to the inverse tangent of the opposite over the adjacent. So that's going to be approximately 34 degrees. And since the acute angles of a right triangle are complementary, we've got 90 minus the 34, then the measure of angle B must be about 56 degrees. Now we need to find C, that side length, okay? And the sine of A is the opposite leg over the hypotenuse, that's 5 over C. That means, because we know A is 34 degrees, the sine of 34 degrees is equal to 5 over C. And C is equal to 5 over the sine of 34 degrees, which is approximately 9.01. So what happened here was, we know that the inverse tangent of 5 over 7.5 is the measure of angle A, that's 34 degrees. So when we had the sine of 34 degrees here as the denominator, that's it here, see? We've got 5 over the sine of 34 degrees. That's approximately 9.01. And if we wanted to, we could check our math with the Pythagorean theorem and see if 5 squared plus 7.5 squared is approximately 9.01 squared, okay? So remember from the previous video, the inverse sine of x is the angle whose sine equals x. The inverse cosine of x is the angle whose cosine equals x. and the inverse tangent of x is the angle whose tangent equals x. And remember the SOHCAHTOA, because that's going to help you with the opposite over the hypotenuse, or the adjacent over the hypotenuse, or the opposite over the adjacent, okay? Solving a right triangle in the coordinate plane, the coordinates of the vertices of triangle JKL, right here, are J is -1, 2, K is a -1, -3, and L is a 3, -3. And we can find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So the first thing we're going to do is find the side lengths. We plot the points for J, K, and L, and we get this triangle. And if we look at it very closely, we can see, if we count, we got 1, 2, 3, 4, 5 for JK, and we've got a 1, 2, 3, 4 for the length of KL. Then, to find JL, we use the distance formula and the ordered pairs for J and the ordered pairs for L. And after doing the distance formula, we get approximately 6.4. So we know that's about 6.4. Now we find the angle measures. Well, we know that the measure of angle K is 90 degrees because JK and KL are perpendicular. And the measure of angle J up here is going to be the inverse tangent of the opposite over the adjacent, the 4 over the 5. And in our calculator, we find that's approximately 39 degrees because segment KL is opposite of angle J and segment JK is adjacent to angle J, okay? And the measure of angle L is going to be the 90 minus the 39. And we have an approximation symbol, so that's going to be approximately 51 degrees. The acute angles of a right triangle are complementary, okay? Now take a look at these pictures. Look at this picture here. Look at that street. It's pretty steep. So that's Lombard Street in San Francisco, and it has 8 switchbacks because the hill is so steep. So a switchback on the side of a hill or a mountain, when they build the roads, they don't want the percent grade to be very steep, so they make these switchbacks like this, so the grade isn't, you know, a dramatic percentage. And this is what it looks like from above. It kind of looks like a snaking river, doesn't it? Yeah, that's Lombard Street in San Francisco. So if the hill, not the street, if the hill has a percent grade of 84%, what angle does the hill make with a horizontal line? We round to the nearest degree. Well, if it's an 84% grade, that's 84 over 100, that means the hill rises 84 feet for every 100 feet of horizontal distance. So it rises 84 feet for every 100 feet of horizontal distance. And this measure of angle A here will equal the inverse tangent of 84 over 100. And on our calculator, we can find that it's approximately 40 degrees. So we know that the hill will make a horizontal line down here, and the angle of its slope would be 40 degrees. And this isn't even the steepest road in the world. I think that's in New Zealand, okay? So I want you to remember, don't use approximate amounts to find other values, to find other amounts. So when we found that the measure of angle J was approximately 39 degrees, don't use it to find a side length or something because it won't be as accurate, okay? Try to use the given values. And if you're not given a diagram, try drawing a triangle on a grid to visualize the problem. It might help you, okay? Our next lesson is angle of elevation and of depression. It's 8.4a. Then we're going to finish 8.4 with indirect measurement using trigonometry, okay? So YouTube, August of 2018, got rid of the stabilization tool in their editing, and I've been using that for 3 years. And now I'm using other programs to try to stabilize my videos, and they aren't doing as well. So I apologize for any shakiness, and I'm doing the best I can. And I hope you're okay, and I will see you next time. Bye.